Today, we're doing a deep dive into something that really powers the modern internet: site reliability engineering, or SRE, and observability.
Right. We'll be looking at the sources that define these, well, critical practices.
And we'll check out a real-world example from Fender, yes, the guitar company.
But then there's a twist. We're going to connect all this tech back to some, let's say, surprisingly ancient ideas about wisdom and structure.
Yeah, our mission for you, the listener, is to see how aiming for, super high uptime, like 99.999%, actually leads us to thinking about failure.
And even ancient geometry and philosophical concepts. It sounds wild, but there's a real connection.
Exactly. We're going to show how chasing those 5 9s forces an acceptance of failure, which, believe it or not, ties into some foundational principles. Let's unpack this. Okay, so site reliability engineering, SRE. The sources quote Google's Ben Sloss saying it's what you get when you treat operations as a software problem.
Right.
How does that actually change things day to day compared to, say, traditional IT ops?
Oh, it's a huge shift. A total mindset change, really. Instead of just reacting to fires.
Putting out fires, yeah.
Exactly. SRE applies software engineering discipline, coding, testing, automation, to infrastructure and operations work.
So the goal is building systems that are just inherently more reliable and scalable.
Precisely. Highly reliable, highly scalable systems. And for the end user, that means things just work better, more predictable, better performance.
And the sources really hammer home that reliability is maybe the most important feature.
Absolutely. Because if the service is down, none of the other features matter.
True. So SRE acts like a kind of brake, ensuring that pushing out new features constantly doesn't break everything.
That's a good way to put it. It ensures the speed of delivery doesn't overwhelm the stability. And a key way it does that is by fighting something called toil.
Toil. I like that term. What exactly is toil in this SRE world?
So toil is basically the repetitive, manual, kind of grunt work of operations. Stuff that doesn't add long-term value and gets worse as the service grows.
Like setting up servers by hand every time, or running the same script over and over.
Exactly that. Manual provisioning, password resets, running cleanup jobs. If it's automatable and repetitive, it's likely toil. SRE aims to engineer that human labor away.
Right. The rule is something like, if a human does it 3 times, automate it.
Pretty much, yeah. That's the philosophy. Use software to solve operations problems.
Okay, so that brings up the DevOps comparison. People often say DevOps is speed, SRE is reliability. How do they actually work together?
Well, they definitely overlap. They meet at something called service level objectives, or SLOs.
SLOs, okay.
Think of it like this. DevOps helps streamline how fast you can make changes. SRE puts guardrails on that speed, using SLOs to define how reliable the system needs to stay despite those changes.
So the SLO is the actual target. Like, we promise 99.9% uptime.
Exactly. It's a measurable goal, agreed upon by business and tech, that links reliability to what the users or the business actually need.
But even aiming for 99.999%, that's not 100%. There's still a tiny bit of expected downtime baked in.
And that's crucial. The sources are really clear on this. 100% reliability is basically impossible or way too expensive to be practical.
Right.
So by setting an SLO below 100%, you create what's called an error budget.
An error budget, so like an allowance for things to go wrong.
Precisely. It's the acceptable amount of failure. This budget is key because it tells engineers when it's okay to prioritize building new features instead of over-engineering for reliability that might not even be needed.
Ah, so you aim for reliable enough, not perfect.
Exactly. Reliable enough, and that acceptance of imperfection.
Right.
That's where we start seeing the philosophical echoes later on.
All right, moving on from SRE basics, let's talk about monitoring and observability. These often get confused. How do we separate them?
Yeah, they're related but distinct. Let's use an analogy. Think of monitoring like the dashboard in your car.
Okay, speed, fuel, warning lights.
Exactly.
Right.
It tells you about known conditions using predefined metrics. Is the engine overheating? Is CPU usage too high? Is the error rate spiking? It's based on things you already decided were important to track.
So it watches for problems you anticipate.
Right. It's the Watchtower looking for expected threats based on known symptoms. It alerts you when a specific threshold is crossed.
But what about weird problems? Things you didn't expect, the unknown unknowns. That dashboard won't help much then.
Exactly. And that's where observability comes in. Observability isn't just about dashboards. It's a property of the system itself. It's about being able to ask new questions about your system from the outside without needing to predict the failure mode in advance.
So it's more like being able to, pop the hood and really dig into why the car is making a funny noise. even if no warning light is on.
That's a pretty good analogy, yeah. It allows deep introspection to troubleshoot novel problems you couldn't have written an alert for.
And getting that level of insight requires the system to produce the right kind of data, right? Telemetry data.
Correct. The sources highlight three key types of telemetry signals needed for true observability. They are logs, metrics, and traces.
Okay, metrics we sort of covered with monitoring numbers over time, like CPU usage.
Right. Aggregated numeric data. Logs are time-stamped event records. Think of a diary entry for the software. They're useful, but often lack context on their own.
And the third one, traces. That sounds important for modern systems.
It's critical, especially with microservices. Traces, or distributed tracing, track the entire journey of a single request as it travels through all the different services in a complex system.
So instead of just seeing that one service is slow, you see the whole chain reaction.
Exactly. A trace is made up of spans, where each span represents a specific piece of work, like one API call or one database query.
Ah, okay.
Tracing connects all those spans together to show you the full path, and crucially, where the delays or errors actually happened. Metrics and logs alone often can't give you that full story.
Okay, theory's good, but let's make it concrete. The Fender case study. Iconic guitars, but they're big and digital now too, like their Fender Play learning app.
Right, and they had a very common problem. Their traditional monitoring focused mostly on the back-end systems.
So they knew if their servers were okay, generally?
Yeah, they had aggregate metrics. They might know, say, that the average page load time was acceptable, or that 5% of users experienced an error.
But they didn't know which 5%, or why their experience was bad.
Precisely. Was it their code? A slow, third-party ad script. A specific browser version. The aggregate data smooths over all those crucial individual details they couldn't drill down.
So the solution was to bring observability to the front end, to the user's actual browser.
Exactly, implementing front-end observability. This meant collecting that rich telemetry logs, metrics, and especially traces right from the user's device.
And how did that help them pinpoint those individual issues?
The key was using open telemetry, which is an open standard for this stuff, making it easier to instrument their code.
Okay.
And critically, they started tagging the traces with user identifiers. So if a user complained or if they saw an outlier, they could pull up the exact trace for that specific user session.
Ah, so they could see the whole journey for one person, step by step.
Exactly. See exactly which calls were slow, which resources failed to load for that individual. No more guessing based on averages.
That must make a huge difference for tuning performance. Did they focus on specific metrics with this new visibility?
They did. One key metric mentioned is largest contentful paint, or LCP.
LCP, right, that's one of Google's core web vitals. It's about perceived load speed.
Yeah, basically, how quickly does the main, most important thing on the page become visible to the user, like the main image or the video player? If that's slow, the user feels like the whole page is slow or broken.
So front-end observability let them really optimize that specific user-centric metric.
Correct. Fine-tune the code, identify problematic scripts, and directly improve that perceived performance.
And Fender's director of platform engineering, Michael Garsky, his quote really nails it. The risk of not having this is just not knowing what's happening.
It really is about regaining control and understanding in a complex environment.
Okay, we've covered SRE, observability, Fender. Now for that philosophical leap. The sources connect this very modern technical pursuit of reliability back to, well, ancient wisdom. How does that work? Is it literal history or more of an allegory?
It's definitely presented as a conceptual allegory, but a really insightful one. The idea is that building and maintaining these complex digital systems requires the same kind of foundational principles as, say, building a cathedral or any great and important undertaking.
Okay.
These principles are framed as three pillars: wisdom, strength, and beauty.
Wisdom, strength, and beauty. All right, let's break that down. How does wisdom map to SRE? The sources say it's the ability to contrive, to design.
Right. In SRE terms, wisdom is the planning and design phase. It's defining your service boundaries, figuring out what actually matters. Those are your SLIs, service level indicators.
The things you measure, like latency.
Exactly. And then using those SLIs to intelligently set your SLOs, the reliability targets. It's the thoughtful, upfront work of designing for reliability based on actual needs. That's the wisdom to contrive.
Okay, makes sense. Then strength, the ability to support. That sounds like reliability itself.
It absolutely is. Strength is the engineering muscle needed to build and maintain that reliability. In SRE, this maps directly to eliminating toil.
Replacing manual work with robust automation.
Precisely. Building automated systems, implementing robust testing, creating infrastructure that can actually support the SLOs you defined. It's about building inherent strength into the system, not relying on brittle human effort.
Got it. And the third pillar, beauty to adorn. How does adornment fit into keeping servers online? That seems like a stretch.
Well, think of beauty not just as decoration, but as elegance, simplicity, clarity. In SRE, beauty is about reducing unnecessary complexity.
Making things simpler, easier to understand and manage.
Exactly. Sometimes boring technology is beautiful because it's reliable. Beauty is also found in the process of continuous improvement, like conducting thorough post-mortems after failures to learn, adapt, and remove cruft. It's about making the system elegant and maintainable over time.
Wow, okay. Wisdom to plan, strength to build and automate, beauty to simplify and refine. I can see the parallel, but why bring geometry into it?
Geometry in this context represents order, predictability, foundational truth. It's historically seen as the basis for understanding the physical world and for building stable structures.
Like building a temple requires geometric principles.
Right. And building a vast, complex, distributed software system is also an act of imposing order on potential chaos. SRE practices, like defining clear boundaries and metrics, echo that geometric pursuit of order and stability.
So geometry is the foundation. What about the classic tools of geometry? Mentioned the square, the level, the plumb rule. Do they map too?
They do, as sort of moral or operational guides derived from the tools. The square, used to ensure right angles and true surfaces, teaches morality or fairness.
How does that apply to SRE?
Think about setting that error budget. The square represents doing it fairly and honestly, based on real needs, not just arbitrary numbers, bringing unruly reality into proper form.
Okay. And the level for ensuring horizontal correctness.
The level teaches equality. In SRE, this could mean applying SLOs consistently and fairly across different services or teams, ensuring a level playing field for operational expectations.
Right, no favorites. And finally, the plumb rule for vertical trueness.
The plumb rule teaches justness and uprightness. This connects directly to the idea of blameless postmortems.
Because you're focused on the systemic issues, the vertical truth of what went wrong, not pointing fingers.
Exactly. It demands an upright, honest investigation focused on system improvement, not individual blame. It's about learning truthfully from the failures that your error budget allows.
That's actually a pretty profound connection from Google SRE and distributed traces all the way back to these foundational, almost Masonic principles of building.
It really highlights that achieving operational excellence isn't just about the tech. It's a continuous process that needs technical rigor, yes, but also this deeper sense of structural integrity and reflective practice. Hashtag tag outro.
So, quite a journey today. We started with SRE treating operations as a software problem to build reliability.
Right, focusing on automation to eliminate toil and using SLOs and error budgets to balance speed with stability.
Then we distinguished monitoring for the known problems from observability,
which is key for the unknown unknowns, using that rich telemetry of logs, metrics, and especially traces to ask new questions.
We saw how Fender used front-end observability and OpenTelemetry to really understand and improve individual user experiences, focusing on things like LCP.
Yeah, moving beyond just averages to see the specific user impact.
And finally, we connected it all back to those pillars: wisdom, strength, and beauty, and the geometric principles of order and uprightness reflected in SRE practices like blameless postmortems.
It really underscores that managing these complex systems is an ongoing effort. You need the rigorous monitoring for what you expect, but also that deep observability, that willingness to have a beginner's mind for the unexpected issues. That combination builds the wisdom needed.
And that SRE goal isn't perfection, but reliable enough, making sure engineering effort goes where it adds the most value, not just chasing impossible uptime.
Exactly. It's about efficient, sustainable reliability.
So we want to leave you, our listener, with a final thought to chew on. Thinking about that principle of reliable enough and avoiding unnecessary toil. How might you apply that in your own work or even your life?
Yeah, where are you spending effort on manual repetitive tasks, your personal toil, that could perhaps be simplified or automated, freeing you up for more valuable things? What does reliable enough look like for you?